So here's this optimization problem. Ready? A rectangular page is to contain 24 square inches of print. The margins at the top and the bottom of the page are 1.5 inches, and the margins at the left and the right are to be 1 inch. What should the dimensions of the page be so that the least amount of paper is to be used? The least amount of paper. Is everybody okay with why this is a minimum? Here's a clue right here. Right? Asking for a minimum here. So this is, in any case, I would draw this picture. Here's our page. I'm going to let this length be y. And this length be x, if you don't mind. And there are some issues here, aren't they? Because if you look inside here, this is what I think the book doesn't really talk about enough, is that this is the width y right here, isn't it? And here is the length x. So what's the importance of this green area inside the green box here? What is this? Yeah, right, it's the printable area. It's the printable area here. The printable area is here. And then we know we have margins for y. And the left to right margins are 1 inch each, aren't they? So we have 1 inch left margin, 1 inch right margin. And then the vertical margins are 1.5 and 1.5, aren't they? So now let's try to find this. What is the area to be minimized? Algebraically. Well, what's the width? How wide is that page, algebraically? It's wider than y, isn't it? How much wider than y is it? Right, y plus this right margin and y plus this left margin. Exactly, good. You know what? Thank you. Can I just even do this? Because, right. Y is the width of the green area here, isn't it? It's really good. And therefore, thank you, Charlotte. Then x is this, isn't it? X is truly this. That's really smart. So x is this distance right here, isn't it? So the x plus what? What is x plus? We had y plus 2 is the horizontal width. What's this here? It's x plus 3. This is the length of that whole page, isn't it? Because we need a rectangular page is to contain 24 square inches of print. So we need this 24 square inches of print here, don't we? So it just means the green area, but we're confined by the fact that no matter what size page we use, we can make this y value, we can make it thinner or wider, but whatever we do, we have to add 2 inches because we have to add an inch left margin and an inch right margin. So we're forced to do that. So we need to get 24 inches in here. It's not automatic what it could be. It could be lots of things, couldn't it? I guess it could be 1 in 24.
So A equals that, and then
A equals this area, because this is the area to be minimized, isn't it?
y plus x, or y times x has to be.
Exactly right. So is this, very good, is this area right here, is this the primary, or is this the secondary equation? It's primary because this is the area to be minimized, right? So that's how we decide what's primary. So this is primary right here. So this is the primary equation. is right here. So you're taking that AP exam and you're setting this up before you even worry about all the calculus of it. Just set it up correctly. So there's the, and then Charlotte, you had said the secondary equation is that area is what? Right. Right. XY equals 24. Is this area? Should have written this in green, Charlotte, right? I should have written this in blue and this in green. But you're right. So this times this has to equal 24, doesn't it? So we go to here and say, okay, XY equals 24. And we're going to label that as our secondary equation. Well, that's our secondary equation there. We have the same issue that we're going to keep running into with these optimization problems, which is what? We have two variables here, the variable y and the variable x. This is single variable calculus, so we can't do that. But what can we do? Yeah, solve the secondary in terms of, right, I can find a replacement value for this y right here. So what I'm going to do is I'm going to try to do that. I'm going to try to find a replacement value here. And I'm going to say, you know what, I'm going to try to replace this y right here with this y right here. Right? Is that okay? So y equals what? If you just do some quick algebra, y equals what? Equals 24 over x. So what I'm going to do now, I'll wait for a second. I'm going to do now, so I'm just going to rewrite this primary equation here and substitute this into it. So substitute the secondary equation. Into the primary equation. So I had all that written in green up here, so if you don't mind, I'm going to do this. Say that area, I'm just recopying this. Area is equal to, but this y is this y. It says here that y is 24 over x. So y is 24 over x. What? Yeah, plus 2. This 2 right here is this 2 right here, isn't it? And then x plus 3. And now we have this form that we want to maximize, don't we? So you can FOIL this. Is everybody okay with how we got this 24x? Is everybody okay with the fact that we have our equations, we have our secondary equations substituted into our primary equation? So we have both equations now in one equation, don't we? Okay, good. And if you FOIL this out, this FOILs out to a equals 30 plus 2x plus 72 over x. Is that where it came from? I actually didn't do this FOIL. Does it?
You have 24 over x times x is just 24, and then you have the 2 times 3.
So yes, that's good. Thank you very much. So it was 24 times this x is just 24, yes? 2 times 3 is the 6. So is that where that came from? Thank you. That's good algebra. Now what do we want? Yeah, so let's take right? It's the derivative of a with respect to x, isn't it? Otherwise known as a prime. And a prime is, well, what's the first derivative of 30? 0. First derivative of 2x. Isn't it true that 72 over x can be written as 72 times x to the negative 1? Yes? And therefore negative 1 times 72 is negative 72. Negative 1 minus 1 is negative 2, so this would go back under here, wouldn't it? So far, so good? Okay. So this is a derivative. To find the maximum and minimum value, what do we want to do here? Right, set this equal to 0. So we have 0 is equal to 2 minus 72 over x squared. Just some quick algebra, if you don't mind. 2 equals 72 over x squared. Is that all right? I know hopefully you're saying I added negative 2 to both sides, yeah? I got a negative here, a negative there. I just multiplied the whole thing by negative 1. So this negative became a positive in the other. Is that okay? All right. Now what? What's the algebra of this now? Yeah, if you don't, I just cross multiplied here. Is that all right? Can you see this? Can you see it better now? I multiplied this times this. If you can shortcut that, it's fine with me, but end up with 2x squared equals 72. X squared equals 36. X equals plus or minus 6. Is that okay? We can automatically disqualify one of these numbers. Which number do we know is not the solution? Negative 6 can't be the number. Why is that? Right, we're talking about a distance here, right? We're talking about a length. We can't have a length. Right, x must be greater than 0 is our domain. So x equals 6. And if x equals 6, we would have, where is this? Let's go back to this. If x equals 6, I just go back to this if you don't mind. So if you want to plug in those values here, x equals 6. So we had area equals 24 over x, isn't that right? Right? Over x, and x was 6. Plus 2, is that right? Times x plus 3. X was 6, so 6, sorry. 6 plus 3. And this is 4. Yeah? 4 plus 2 is 6. 6 plus 3 is 9. All good? That's all I have for you today.